Okay, last but not least is some code to do uncertainty maps. There's certainly a lot of different ways to do this, but this is some R code that will do it for a point data set like those we've been working with. And the idea is to create a additional column in our table that has the standard deviation of the residuals from multiple Monte Carlo runs. So that's going to be the error, would be the standard deviation of the residuals. So pretty typical code to start, just loading up our data set and then do NA omit. Now the method I'm using is k-fold validation, and I'm going to do 10 k-fold validations, and then I'm going to repeat that twice. I'm only doing it twice for time on this video. You'd probably want to do it about, I don't know, 10 times. Be interesting to see what the response is and when it stabilizes. Okay, so then I create a residual matrix. This is the matrix that's going to contain rows for each of the rows in our data, and then it's have columns for each of the times that we do a full k-fold cross-validation. Now the reason I'm using k-fold cross-validation is because it will produce a value for each point in our data set, and we're guaranteed to get that. If we do a random 30-70 split, we're going to get multiple residuals for each point, and we need some additional work to be able to manage that. So in this case, I've just got one column for each of my times that I run a full k-fold cross-validation. Now, part of doing that, because k-fold randomizes the data before it puts it in buckets, is I create a sequence to identify each of the original rows in the data. And then here's our outer loop where we're going to loop through and repeat the cross-fold validation. Here's where I shuffle the data into a new data set and then create the folds. So here's the number of folds that we're creating, and this will break it up into 10 buckets. And then we go ahead and repeat this for each fold. So first finding the test indexes to our data using the fold count. So this is where we'll go through each of the different buckets, pulling each bucket out as a test. We pull that as the test data, and then we pull out the training data as the ones that aren't the text indexes. And that's what this negative does. That says everything but the indexes that are in this array. Okay? Then we go ahead and do a GAM and do a prediction. We get residuals. So our response variable, which in this case is height. Yeah, I should have mentioned, here's our GAM with height, annual percip. This could, of course, be any modeling approach that we've done where we do a model and then we do a prediction. And then we get our test prediction. Those are our predicted values, so we can just subtract those from height, and that gives us the residuals. Then I go back and I get the original indexes for our test points. And then this little loop here goes through each of our residuals and finds its original index, the point that it maps to. Strips off a name because R adds a name to this. For some reason, we do a subtraction. It turns it into a vector or a named value, so we just have to rip that off, get to the actual value, and then we put that into our matrix based on the original index, and then our loop count, so we can add that to each of the columns as we go across. This is interesting in that you probably haven't seen this before. It's a loop within a loop. So here's our fold count, and then here's our overall loop count. So it's a loop within a loop within a loop. You want to be a little careful with your counts, make sure they're all in the right spot, otherwise it will just sit and loop forever. These are also a little bit challenging to debug. So if you're going to come and use this one, I would start with just changing the modeling part of it, this section, to fit with your modeling method, response variable, and covariates. And this as well, so this piece of it. The rest of it should work. Of course, file paths will have to change. And you want to play with these variables as well. Okay, so let's go ahead and run it and see what we get. And what you can see is here's our residual matrix where we've run through and added a residual for each run. Notice they're similar but a little different. Okay, and that's our residual for how far our model is varying from our data. And then we can use row standard deviations to compute the standard deviation of each row. Of course, there's just two in this case. And that gives us that. So there's our standard deviation. And then we can go ahead and run this, and now we have our residual standard deviation. Now the question is, what do you really want to put in a map, right? Because this is just a standard deviation of the distribution of the residuals, which is interesting as we do multiple times. But I think we would also want the mean value of the residuals, right? We want to find out what's the average, how big are the residuals across our map, as well as the row standard deviations. And there is a row means function, and we can just go ahead and add another column to our data for our means. And we could do other things. And there we go. And now we have a new data set that we can write out to our file. Sorry. And it has a standard deviation and a mean for our residuals based on doing multiple k-fold cross-validations. Have fun.